Hello friends, today we will discuss about G Fanuc Versamax PLC programming, downloading and simulation. So this is the first window. We will create an empty project. You select this one. Okay. You will give a name P a target G Fanuc controller Versamax micro PLC. Nano micro. I have micro PLC. So now this tree is already created. Here hardware configuration. This is by default. This is the CPU number of Versamax PLC. Now we will create the program block. Now it is empty. We will make a program for a motor starter. So we will use this contact blocks, normally open or normally close. Then one coil for motor. This is for start bus motor. This is for stop bus motor. This one motor. And now we have for a motor there is one golden contact is required to so that the motor will get continuous supply. So we will one block here. And this is a vertical or horizontal connection. Then we will have two indications. One is motor on indication and one is motor off indication. So we will use nano block here. It will give an output and one MC block. It will give one more output. Now we will give variables. New variable boolean. So the first one is start. So here you have to give a reference address. This type of input. This is discrete input or digital input. Now you can see it is assigned our number I1. Then we will create one more. It will be stop. This is also digital input or discrete input. So it is by default to 2. Now the motor, it is output. New variable boolean. The motor. This is discrete output or digital output. Now we see that motor is gone up. We want to, it should be, so here we will sort it by address, so that start stop motor is in sequence. Now here we will assign our IP start. This is motor. This is golden contact for motor. Now this is the on indication. When the motor running, it gives an indication. So this also give motor. This is your Q2. It's still not assigned. We will assign one more output. This is your motor. M on or MOT or motor on. I will give one more. Motor off. This one will assign first, motor on. This will be your digital output. Motor on. So it is already Q2. Now we make one more.
This is our board, electrical board for system integration. And this is our G connector PLC. Now we will power on. You can see the two LEDs is blue. One is for power. If power is okay, it will give okay indication. If everything hardware is okay, it will give okay indication. Then you run, and then there will be one more indication will come, run indication. So this is a 16 input and 12 output PLC.
before downloading the program, we have to validate it. So now validate. The message is validating complete, zero warning, zero message. Now we will go to online. Now the device is connected. Here
Q3 is on. Q3 means motor off indication.
now we will force the input. Now we will force the start. Now you can see the motor current starts flow from here. This is NC button. This is hold on contact. The motor on and motor on indication on. This one we can see in the controller also.
Then we can see in the PLC that Q3 is off and Q1, Q2 are on.
Now the motor is in running condition. So two indications are on, motor on and motor on. Now we will apply force on stop this button. Now see the current break here, the motor off and the indication gone, on indication, off indication on. This one we can see in the controller also, PLC also.
Now you can see only Q3, this is motor off indication is on. Good morning friends. In the last session we have seen the overview of our 1500 kVA control panel power diagram and the control diagram. So here there is a main incomer which is feeding to the copper bus bar system. Bus bars are the copper flat bars. It is used instead of wire, flexible wires due to some technical reasons.
Hello friends, today we will discuss about G Farmak Versamax PLC programming, downloading and simulation. So this is the first window. We will create an empty project. You select this one. Okay. You will give a name PME 14 July 22. Then OK. Then right click, add target, G controller, Versamax micro PLC. No, micro, I have micro PLC. So now this tree is already created. Here hardware configuration. This is by default. This is the CPU number of Versamax PLC. Now we will create a program block. Now it is empty. We will make a program for a motor starter. So we will use this contact blocks. Normally open, one normally close, then one coil for motor. This is for start bus button, this is for stop bus button, this one motor. And now we have for a motor, there is one golden contact is required to so that the motor will get continuous supply. So we will one block here. And this is a vertical or horizontal connection. Then we will have two indications. One is motor on indication and one is motor off indication. So we will use one block here. It will give an output and one NC block. It will give one more output. Now we will give variables. New variable boolean. So the first one is start. So here you have to give a reference address, this type of input. This is discrete input or digital input. Now you can see it is assigned one number I1. Then we will create one more. It will give stop. This is also digital input or discrete input. So it is by default to 2. Now give motor, it is output. Give variable boolean, give motor. This is discrete output or digital output. Now we see that the motor is gone up. We want to, it should be, so here we will sort it by address, so that start stop motor is in sequence. Now here we will assign the or IP start. This is motor. This is holding contact for motor. Now this is the on indication. When the motor running, it gives some indication. So this also give motor. This is your Q2. Still not assigned. We will assign one more output. This is your motor. M on or MOT on. O motor on. We will give one more. Motor off. This one will assign first. Motor on. This will be your digital output. Motor on. So it is already Q2. Now we make one more.
This is our board, electrical board for system integration. And this is our G-Connect PLC. Now we will power off. You can see the two LEDs will do. One is for power. If power is okay, it will give okay indication. If everything hardware is okay, it will give okay indication. When we run, one more indication will come down indication. So this is a 16 input and 12 output PLC.
Before downloading the program, we have to validate it. So now we will validate. The message is validating complete, zero warning, zero message. Now we will get online. Now the device is connected. Here we can see the Q3 output is on because the motor in off condition. So this is in motor off indication is on. That one we can see in the PLC also.
Q3 is on. Q3 means motor off indication.
Now we will force the input. Now I will force the start. Now you can see the motor current starts flow from here. This NC button, this is hold and contact, the motor on and motor on indication on. This one we can see in the controller also.
Then you can see in the PLC that Q3 is off and Q1, Q2 are on.
Now the motor is in running condition. So two indications are on, motor on and motor on. Now we will apply force on stop push button. Now see the current brake here, the motor off, and the indication gone, on indication off, indication on. This one we can see in the controller also, PLC also.
Now you can see only Q3, this is motor off, indication is on. Good morning friends. In the last session we have seen the overview of our 1500 kV air control panel power diagram and the control diagram. So here there is one main incomer which is feeding to the copper bus bar systems. Bus bars are the copper flat bars. We use instead of wire, flexible wires due to some technical reasons. Then from the bus bar there will be one branch breaker Q1. It will be Q1 will feed to three set of contactors K1.1, K1.2, K1.3. Again one release contactor will feed to capacitor of banks parallel to each other. And here it is 25 kVR, 25 kVR, total 50 kVR. Designation is 1C1 and 1C2. The second set is K1.2 and it is feeding to 1C3, 1C4, 50 kVR, 25 kVR edge. The third set is K1.3, it is feeding to 12.5 kVR edge contactor capacitor banks. Designation is C1C5, 1C6. For the other branches, we have represented in a single line diagram form. The branch breakers are Q2 to Q12 and the contactor and the capacitors are designated accordingly. Coming to the control circuit, we have our 480 volt system. But since some components are wired onto the door like push button pilot lights, this 480 volt cannot be used as a control voltage, because by some accidental contact, if you get somebody touch the come in contact with any light parts, he will severely get shocked. So we have to reduce the voltage to a safe limit. So our control voltages are 230, 110, 48, 24, AC or DC, depending on the system requirement. So here we have one control transformer, 480 by 230 volt. It is connected to phase, either RY, RYB or BR. Then in the primary, there will be one fuse protecting the coil of this transformer. And secondary, there will be one fuse. So here the output will be 230 volt AC. This is phase and this is neutral for the control system. Now there will be one auto manual switch. In auto mode, when the switch turn to right auto mode, the power come to here and there will be one controller contact inside the controller. Depending on the signal, it will be switch on, either close or open. So when it close, the power come here and all the this contactor coils are get energized. So contactor is like a magnetic switch. When this coil gets supplied, with the magnetic field forms and it pulls a moving part. So one fixed part and moving part are get closed here. So since there is a pilot light parallel to the coil, so it gives indication that the contactor is switched on. So obviously it is when the contact switch on, the capacitor will be charged. So this PL1 when glow, it will be indication that capacitor banks are on. In manual mode, when switch is to turn to left, the supply come here, and then it pass through a stop push button or an open push button. It has a normally closed contact. Normally closed means in normal condition it will be this contact remains always closed condition. And this is one closing push button. This is normally open contact. These are all spring operated. So when you press this, the contact current come here and come to the this contact to get supply. But when you release this switch push button, this contact gets off. So to latch it, we are using one NO contact of this contactor as well as latching. The function is like this. When you press this button, this energizes, and the auxiliary contact is some contact. It is some auxiliary contact. It closes. When the coil gets supplied, this also closes, and now current carries this path and this path. So even when you leave this push button, the current continues in this path. So it remains in the closed condition. If you want to break the switch, break the path, you have to press this. If you press this, then this will not close automatically unless you press it. And there is a center of opposition, automatic switch of center of opposition. When you want to de-energize the system, if you don't want to operate in either auto or manual mode, you can put in center position. Or if you want to make some maintenance or repair work, you can put this in center position. For others the same principle, but here the switch is gang operated. When you turn the switch to manual mode, all the switches will be turned, all the contact will be changed to manual mode or auto mode. And here this is general representation for circuit PL2 to 12. So pilot sides are represented by PL2 to PL12. Now in the next chapter we will see the wiring diagram of the controller. This is a typical diagram of a controller. So here our supply voltage is 230 voltage control supply. Now this controller has options for 400 volt, 230 volt, 110 volt, and 0 is common. We will apply the voltage depending upon availability. And there is 2 points K and I. This is crucial because these 2 points receive the signal from the main panel, main system. Main system means, suppose this is your main panel. It has feeding to blower, water pump, lift, lighting, workshop, exhaust fan, all the loads. So some loads are like blower, water pump, or inductive loads. So depending upon the operation of these loads, the power factor, the current, nature of the current is lagging because of inductive load. So depending on the load, this will give these are the current transformers for metering of this panel, but there will be one fourth CT current transformer. This will feed to this point K and I. So this is a comparator. Inside there we have to put the target power factor 0.98 or 97 or 96, and the comparator will compare the nature of the power factor of the system, and it will give signal to close these contacts 1 to 12. So depending upon how many kVA are required, these contacts are closed or open. Suppose the load is some loads are switched off, then the power factor improves. So in that case, some capacitors are switched off automatically defined by this controller cortex. Here, this point A is for supply is coming from here because the current should pass through the contact and come to this is a relay or contactor. Some cases, if the contactor size is small, it actually feeds the contactors, and in some cases, if the contactors are big size, or there are more than big more contacts. Like in our case, we have 3 contactors in parallel. So the load comes to this point. In that case, this contact will burn, and since it is inside the contact, we can repair it. In that case, so to avoid this, we are using one small relay. It will have only a small auxiliary contacts, and this so this contact will not damage, and this yellow contact will energize the main contactor, big power contactors. This is called capacitor duty contactors, because there are many types of contactors, lighting contactor, for motor or switching contactor, but this is special type, so this is called CDC or capacitor duty contactors. Now in the next topic we will see use of reactors, D2 reactors. Okay. So this is the overview of our system. The left side upper portion is a power diagram. The lower side is control diagram. And right side is a controller diagram. And extreme right side is main panel. In the next topic, we will discuss about the D2 reactors and the creation of pillar metal for this panel. So this is the electrical equivalent of or electrical diagram equivalent of the logic. In our electrical diagram, we have one auto manual switch. So here, this is the auto. So here, that one is represented by one interlock. Means if you try to close both switches, you see what happens. Now this is in manual mode, so one on, and when this auto mode on. When I try to close this, when auto is on, I try to close this. You can see both the are off because the current is blocking up to here. Red line means there is a blocking current. Blue means there is no current. So because of interlock between these two, the line is blocked here. Okay, then we have our push buttons. We have our manual mode. We have push buttons. We are represented by. So suppose we will put this in our manual mode. You will see all the manual modes are closed. Here this is a 4-stage controller. So there will be 4 stage Q1. Then here one second stage. This is 3rd stage. And this is 4th stage. So you can see all the manual modes are on. Now we will switch on the capacitors one by one. Now this manual mode, I will close this. So by push button, there is one contactor in our electrical circuit. This electrical circuit, when we close this push button, this contactor energizes, and because this contactor is closing one capacitor 10 kVA. So this is our output. This is 10 kVA capacity switched on because of the first set. Now coming to second set. Now we will close this. So this again contacting closing contact K2. And so our second capacitor is 15 kVA which is switched on.
Now coming to third stage, I am closing this. Contact to closing. Contact to closing the 20 kVAr capacitor. So third phase capacitor is on. Now coming to fourth stage. This is the one. Closing K4 and it on. So now all the capacitors are in manual mode. Now I will switch off one by one. So for that I will switch off this push button off, fourth gun, the third gun, second gun, first gun. So this is the manual operation of the push button and contactor and capacitor. Now we will reset all. Now we will turn the switch into auto mode. So this is your auto mode. This is your auto mode. Now turn the color auto, and this is also showing auto mode. Now this is in our diagram. We can see these are the push buttons. When you press this, while control here, this is spring operated. This will be closed momentarily, and this is the one for this is one NO contactor. This is an NC contactor. So these are on off. Then these are the contactors which control which give supply to, which give power to the capacitors. This is a social duty contactor called the capacity contactors. These are the pilot lights. It indicates on or off indication. These are the capacitors. Now this is the controller of the heart of the system. If you will see backside, there will be one switching devices. There are some switching devices. Depending on our requirement, these are give a signal to close the contactors to close open or close the contactors. So now in our system, we will consider this as auto contactor. One signal. Suppose the signal came to switch on one 10 kVAr contactor, so this will close. This is control will give. Now you see this 10 kVAr capacitor is on. Now suppose the demand requires more, additional 15 kVAr. So the second contactor will close from the controller. Now you see one 15 kVAr capacitor is on now. Now it's 25, 10 plus 15. Now still you need 20 kVAr. So what I will do? This controller will give 20 kVAr. Okay. Now this is a 10, 15, 20. 10 plus 15, 25 plus 20, 45. 45, then you need still 25. So this will close. Now all capacitors 10, 15, 10, 15, 20 and 25 all around. Now suppose the some inductive loads are switched off, like blower or pump or some lift, a switched off escalator. Then power factor improvement means suppose you need to reduce your capacitors one switch off. So here switch off is controlling controller 1. So this contactor will open. Now still some further loads are closed, stopped. So we need to switch off on 50 kVAr capacitor. So controller will give command to switch open this contact. Still you need, by this we can switch off automatically switch off all these contacts. So now only all are switched off. So this is the how the controller works. ये एक एलईडी प्रोसेसर सर्किट है, इसमें एक वेरी गुड रेजिस्टेंस है जो है एलईडी का प्लस रेट ज़्यादा कम करने के लिए, और ये उसका एक्चुअल सिस्टम है। तो पहले हम सर्किट सिमुलेशन करेंगे, फिर बाद में इसका करेंगे। तो इसको हम तो पहले हम रेजिस्टेंस कम करेंगे, फिर रेजिस्टेंस से बढ़ाएंगे, अब स्लो हो रहा है। ये एक्चुअल सिस्टम है, ये इसका पॉट है वेरिएबल रेजिस्टेंस के। अभी इसको फ्लैश रेट ज़्यादा हो रहा है, फ्लैश रेट ये पॉट की वजह से। लोएस्ट रेट है, ये हाईएस्ट रेट है। This is the circuit diagram and the light circuit assay motor control system. In place of motor, here we have a bulb. These are the push button, start push button. We can start the motor, we can stop this red push button. And these are the indication lights. This green light indicates when motor run, this glow. The red lamp glow when motor off. And due to some reason, if motor draw heavy current, more current, this motor will trip and this will give the yellow lamp glow. So now we start this motor by pressing this green button, and we can stop by pressing red button. If we want to run the motor or stop the motor from a remote location like control room or control outside plant. This is a remote control station, so we can start and stop remotely. This is a lighting control panel. We can control a light or group of lights by this panel. It has two modes, manual and auto. In manual mode, we can turn to manual position the switch, it will be glow. In auto mode, it will be controlled by this sensor, dark field light sensor, also known as photocell. So now we will turn to auto mode. After sensing light, we switch off the bulb. Now we will make our system dark. After sensing dark, it will switch on the light. It is mostly used in street light application. In the evening, the system will switch on the street lights. In the morning, it will be switch off the lights automatically due to this sensor. Now it switch off due to light. Now this is called programmable logic controller. It is used for automation systems. Now the switch is manual auto switch. Now when we put this switch in auto mode, this motor or bulb will be controlled by this PLC. So it will be there is a sensor here. The sensor is connected to a relay. A relay will give signal to the PLC and the PLC will switch on this light. Now due to presence of light, we switch off. Now we will make our system dark. After sensing dark, it will switch on the light. Now here, this relay was before not activated. After getting a signal, the relay activated, it will give signal to the PLC and PLC give switch on the light. This is how an automation system works. So now we will have a little comparison. It will be conventional system and automation system. In this conventional system, the sensor is directly connected to a panel. But in automation system, these sensors are connected in the field, and from field signals come to activate a relay. Now the relay is in off condition. When we switch off the light, we will get a signal from the field. Now the relay is activated and this signal is processed. So in an automation system like this, lot of parameters we can control. If you want to control temperature, we can connect a signal to this relay, and if you want to control a pump which is filling an overhead tank, when the overhead tank fill, it can stop the motor from this PLC. If the underground tank is become empty, it can stop the motor to prevent dry run. It can control humidity. So many things can be controlled by PLC. Thank you. And we discussed this is known as the programmable logic controller or PLC, which is the heart of the system. The first model is called CPU, Central Processing Unit, like computer. It processes the data. And the second one is extension module. There are two types of input output. One is digital
and another is analog. When we need only switch on, switch off function, we use analog input, analog output. This first unit consists of CPU and I/O, digital I/O, and the second unit is analog I/O. So this when we need continuous monitoring temperature, pressure, or humidity, we connect the data here. The PLC also have many ports for networking, Ethernet port, Modbus, Profibus, all this, so that that it can be, the data can be communicated to different departments in different systems. This is a typical SCADA screen. SCADA means supervisory control and data acquisition. In this screen, every equipment in the plant, graphic made to be for each equipment in the plant, and there will be sensors in the plant. We have to take the data. So here we can see the actual monitoring system. This is a small program for motor control. This is our motor stop condition. This is lamp below. This is motor stop condition. Now from soft switch, from SCADA button, these are SCADA buttons. We can start this from this here. So after this, the motor starts running. This is your motor running indication. Now if you will switch off, it will stop here. Now this is motor stop indication giving. We can start from here again. In case motor overload, motor stop and also give trip indication. So this is a small example of SCADA screen. Thank you.
Good morning, friends. Let us I am introducing myself a little about our projects. This is basically for skill development. We have two sections. One is industrial training and education center. This is very basic level. It will be suitable for those who want to work as a fitter, welder, electrician, industrial electrician, draftsman, computer, etc. And the higher option is electrical control and automation training institute. It is for advanced level people. So this is we are going to start a we are going to give about a particular electrical product. This is called electrical low voltage electrical control panel. Okay. Control panel is like anything that controls the system, like your car or bike, accelerator is a control, brake is a control, gear is a control device. So by using this, you are controlling the vehicle. Here the electrical system also controlled by the device and the product source. If you try to control, you know what happens. The worst thing is it just fire. It gives soft electric shock to any surface. Okay, now this is our product. Now I am going to show you a 3D view of our product. So this is our 3D view product. You can rotate it in any position to view it. Okay. Now let us give some part identification. Now this is the biggest one. It's called air circuit breaker, or in short ACB. Then this is called border case circuit breaker, or MCCB. Okay. Then the smallest one is called miniature circuit breaker, popularly known as the MCB. Now regarding connection, you can see how this one power your cable will connect from bottom side. Then this is a switch, big switch, 4000, 2500, 5500, up to 6300 volt maximum. Okay. It will go to, the current flows through a copper or aluminum bars, flat bars. There is some thickness here, you can see. You can see there is some thickness here, and button and something. So the power transfers from the power starts from here. Then it go to a distributed system. This one, then it comes down. Then here again goes to the branches. This is called branches. This is called main. And this is called the branch. So, this is called main. Incomer. These are called branches. Outgoing or branches. And these are called sub branches. Why it is got four branches? If you see that side, this vector is connected to the direct cable connection outside, but this vector goes to the back side of this. You go to the back side. You go into back side, and there is a called one more distributor system, and from again here, our branches to this mini LCDs. So this is called the sub branches. Our electrical diagram this is our electrical diagram of the system. You can see one incomer is going to here. Same thing we have to electrically. This is called the incomer. This is called outgoing one. This is called outgoing two. Then here shown mistake. It's connected to shown, but it should be comes to will come here and here. That we did not show. Now coming back to our model. Now we have shown in our slide that this is a product inverse mechanical electrical kinetic model. So we will start with mechanical first. Other our first number is now this is dimension. This is dimension important. This is 1000 height, 1 meter height, and there is one more chamber distribution. This one is called busbar chamber. Why it is kept in a separately region? Because nobody will be open this chamber. Only 25% can open this. People will open only this area only. If you want to see something, even this field there will be a door in this. I have not shown it. There is a door only. It will open to the door close condition. But if somebody want to see something, they will open, allowed to see open this area only. This will be closed by like a door, it will be a huge door. It will be hinges to open. But if this chamber is always with a bolted cover. Because it is highly high risk. All these are live parts here. Even this will be also covered. This bar will be covered. If you open, you cannot see this bus. Alright, so let us start with one member. This member. In our drawing, it is 1000. But for workshop purpose, I split it into actually there is a 500. So this is our 500 watt. This is basically a angle of 35 mm 1 inch or 30 mm. The length is our 500 mm. Now we will make it 1000 mm. How? So for that we will add we have several things in height condition. Okay. To make this joint consumer, you need to make a bracket here. Small bracket. One side you will hold weld here. Okay. And one side there will be a welding inside, and there will be one hole here. Then we need one more same piece. So